Hi, in today's video we want to solve the question, the integral from 1 to 3 of 2x plus 3 divided by 2 plus 3x squared dx. Let I is equal to the integral, which is 2x plus 3 over 2 plus 3x squared dx. So we can separate this integral in terms of 2x over denominator, also 3 over denominator. So let us have I is equal to the integral of 2x divided by 2 plus 3x squared, then dx, also plus integral of 3 divided by 2 plus 3x squared dx. So this one can be solved by considering each at an interval, means that we can first consider one maybe as the interval 1, also we have another one as interval 2. So consider I1 is equal to 2x over 2 plus 3x squared dx. You can see the denominator can reduce the numerator, so we are going to bring let u is equal to 2 plus 3x squared. Then from that we can differentiate and remove dx after getting its expression in terms of u. The hope you agree with me. Say du will be equivalent to 6x dx. And now at this point we can get our dx in terms of du, which will be 1 out of 6 du, meaning that if we substitute this expression, which is in terms of du, and put it as dx, means that the expression can be simplified at least. We can solve it very fast because the variables we have reduced them from the numerator and the denominator. So I1 will be equivalent to 2x over u, where there is dx, means that we are going to put there what is the one we have got from the simplification, which is 1 over 6x, then dx, that we shall multiply 1 over 6x du. From that one we can observe very well that x will cancel with x, and then 6 also reduces with 2. And now at this moment we are going to get 1 out of 3, because 2 can reduce with 6, then into 1 out of u du. Then if we integrate 1 out of u, I think you are familiar with those integrals, that they are expected to be having a ln or natural logarithm. So we shall get 1 out of 3 ln u. But what is u? U is equal to 2 plus 3x squared. If we do that, it means it's a matter of substituting, and then we shall get I1 will be equaling to 1 out of 3 ln 2 plus 3x squared. Now the next step is also to consider 3 out of 2 plus 3x squared dx. Let's also try to go on that side and we see, but at least we have got I1, means that the next step is to get also I2. We have I1, let us save it up and we see. So now by considering I2, which is equivalent to 3 over 2 plus 3x squared dx, meaning that this one is observed to be having a tan substitution, means that we work hard so that we can bring in tan in terms of 1 plus anything squared, means that we can bring that anything equivalent to tan theta squared. And now it means that if we put 2 outside, we can easily have a 1 plus something x squared. So we shall say 3 divided by, if we put 2 outside, we remain with 1 plus 3 divided by 2 x squared. And now dx, still like what we did in the previous one, we need to get dx so that we can change the variables. It means that we are going to say to have our tan squared in terms of 3 over 2x squared. So let tan squared theta is equal to 3 out of 2 x squared. What's the purpose of this? We want to use this one to get dx, which is expressed in terms of theta, and then we reduce the variables in the question. So at this moment, if we take the square root, both sides, we shall reduce the orders or the powers. So taking the square root on tan and also on the right hand side, we are going to get our tan theta is equivalent to the square root of 3 divided by 2 x squared will go to x. So what do we do next? Still we are aiming at getting dx, meaning that we shall have to differentiate both sides. Okay, let us do that, differentiating both sides. If we differentiate tan, we get what? We get sec squared theta is equal to constant 3 out of 2, x will go to 1. Now we have the left hand side, we differentiate it in terms of d theta, so it's x squared theta d theta, means that we can have our dx will be equal to sec squared, then divided by root 3 out of 2, then d theta, because now we just wanted to express x in terms of theta. Yes, so let's go the next. Mean that from here we just need to substitute where there is dx. So our integral went to the integral of 3 divided by 2 into 1 plus, where there is 3 out of 2 x squared, we are going to substitute there with tan squared theta. So it will be 1 plus tan squared theta. Then what was our dx? We got it as sec squared theta, then divided by root 3 out of 2, then d theta. What do we observe here? We observe that we can put the constants outside. Even root 3 over 2 can go outside as a reciprocal, meaning that because it is down, so we can have the root of 2 over 3. Also 3 over 2 will move outside, then times root 2 over 3, then the integral sec squared divided by 1 plus tan squared, the whole of this multiplied by d theta. But which relationship do you know between sec and tan? There is. So it will be tan squared theta plus 1 is the same as sec squared theta. So it means that where there is 1 plus tan squared theta, we can put there sec squared theta. So the thing will be 2 3 power 1 and also 2 is to power 1 times 2 power half divided by 3 power half. The reason for half just coming from the square root. So sec squared and 1 plus tan squared, it will just cancel. So remain with integral I2 will be equivalent to, by the rules of indices, it will just remain root 3 over 2. Then theta plus a constant c. So since we have the limits, meaning that we just need to go back and substitute in the every expression and the answer that you have already got. So we have got I2 as root 3 divided by 2 into theta plus c. We just go back and join all the expressions, and then we apply the limit from 1 to 3. Let's have I1 and I2. We know there is a relationship of tan and x, means that we had tan theta was equivalent to root 3 over 2 x. We just want to get theta in terms of x, means that at that point we are going to get theta is equal to tan or inverse, or what we call arctan of root 3 divided by 2 then x. Mean that if we keep on substituting that one where there is theta, it will simplify our work, than going to first express the values in terms of theta, which will bring in the pi's and it becomes somehow complicated. So if you bring I1 and I2 like that, it will be integral from 1 to 3 I1, integral from 1 to 3 I2. So we just need to substitute the limits by putting 3. The I1, it will be from 1 over 3 then plus 2, then 3 times what? X squared. The limit is from 1 to 3 plus integral of the next one I2 is root 3 divided by 2, then theta. But we know what theta is, we have simplified it, we have got it, which will be root 3 out of 2 x. Also it is coming from 1 to 3. The next step is a matter of substitution. The upper integral first, subtract the lower integral or the integral value, so it will be 1 out of 3 in 2 plus 3 times x squared, which is 9, then minus 1 out of 3 in 2 plus 3 times 1 squared, then follow that one, we add there part of tan, which would be root 3 over 2, it is common, so it's a matter of saying root 3 over 2 into tan inverse for the first value, which is 3, and also we do for the second value, which is 1, so it will be tan inverse of 3 over 2 times 3, then minus tan inverse of root 3 over 2 times 1. So it can generally be simplified to, though we have substituted for it, so the remaining part is just for simplification or simplifying just, so it will be in 2 plus 3 times 7, just 29, then minus in 2 plus 5, which is in 5, or what you call the natural logarithm, then plus root 3 over 2, then tan inverse for each, tan inverse 3 or root 3 over 2 times 3, then minus tan inverse of root 3 divided by 2. And generally we can say that we are having the answer, or we are almost at the answer, so it's a matter of just writing it very well, but that is almost the answer. So by joining it, we are going to have the integral from 1 to 3, then of 2x plus 3 divided by 2 plus 3x squared dx will be equaling to, checking from what we have behind, it will be 1 out of 3 ln or natural logarithm of 2 as 29 minus 5, so it will be 29 divided by 5 from the rules of logarithm, then plus the root 3 over 2, then in bracket will be tan inverse of 3 over 2, then times 3, which we had it before, so minus tan inverse of root 3 over 2. So that is the final answer, or you can still simplify it by using a calculator and evaluate it. So really thank you for your time. You can just take time and just select